Simpson's one-third rule in numerical integration is the most efficient approach in determining the area below a curve. Learn more about it here in Numerical Solutions to C problems. Before delving on the different methods, let's compare analytic and numerical integration in solving for areas. Say a function describes a curve and the area under is bounded by a and b. Exact integration utilizes integral strips with dimensions of y and d of x. The total area is then the integral of y dx or f of x dx from a to b to solve for the exact area. On the flip side, numerical integration then adopts the same concept of working with strips, but this time, the number of strips are provided instead of integrated. The area of each strip is solved and the summation is taken. Although Simpson's rule is the most efficient approach, it is somehow limited to only even intervals. The concept is purely based on trapezoid rule, where the area of the curve is divided into trapezoidal strips, which means the two parallel lengths are to be put to action once again. In the case of the curve shown, saying that the area is divided into 4 segments, there are 5 y's created, b1 to b5, to solve for the areas of the trapezoids. The only significant change from the previous method is the final function where the total area is taken as a third of delta x multiplied by the y values taken as b1 plus 4 times of b2, then twice of b3, and then 4 times of b4, then closing it with b5. From the general equation, note that the change of divisor of delta x from 2 to 3, then the alternating 4, 2 coefficients of the middle terms. Let's solve the example of the previous rule and check the difference of results. With y as the integral of 2.5x squared plus 3.75x plus 1 with the limits from 0 to 1.2, we already know that the total base length is from 0 to 1.2, which gives 1.2. Delta x is then the total base length divided by 4, giving 0.3. So the x points are 0, 0.3, 0.6, 0.9, and 1.2. The base heights are computed using these x values. b1 is then 0 placed into the function, which results to 1. b2 is placing 0.3, making 2.5 times the square of 0.3, 3.75 of 0.3 plus 1, giving 2.35. b3 has 0.6 substituted in the function, thus giving 4.15. b4 has 2.5 times 0.9 squared plus 3.75 times 0.9 plus 1, giving 6.4. The last base is 2.5 times 1.2 squared plus 3.75 times 1.2 plus 1, resulting to 9.1. With Simpson's function, the total area is then computed as a third of 0.3 multiplied by 1 plus 4 of 2.35 plus twice of 4.15 plus 4 times 6.4, then add 9.1. The total area is then 5.34. There is a small deviation from the answer we got from trapezoid rule.